What happens when we want to send information from our small office all the way across the globe to a branch office, or out there to a remote user, or to another headquarters office that we have located in some distant country? More and more today, there is an emphasis on wide area networking to make companies so much more competitive, to make them so much more flexible. Now, when you first look at a WAN and a LAN, you realize that, all right, one of the ways we can really distinguish them is coverage area. WANs are covering wide geographic areas, whereas LANs are dealing typically with a building, or in the case of a MAN, a metropolitan area network, you're dealing with just a city coverage. Another distinguishing factor is who owns everything. In a wide area networking environment, there's a service provider who owns a bunch of the stuff. In a LAN, typically everything is owned by the organization. There's a really cool term in wide area networking for whose problem is whose, and that's called the demarc. Yeah, this is short for demarcation. And the demarc indicates, all right, where is the service provider responsible versus where is the company responsible? Is it the service provider that's having a problem, or is it the company that's having a problem that's purchasing from the service provider? So those are definitely unique discussions to have compared to a LAN. In the LAN environment, it's always your fault as the network engineer. Whose fault could it be? You set up the LAN, you own it all. But in a service provider environment, we have to figure out that demarc point when there are problems. Enterprise WANs obviously are in the business of connecting enterprise LANs. Yeah, absolutely. Now, where does WAN technologies fit in our beloved OSI model? Well, certainly the physical. There's going to be cabling and wireless that is trying to do WAN. And then also the data link layer is where we have particular wide area network protocols. They only listed a few here. Wow. They mention frame relay. Well, in some parts of the world, believe it or not, the X.25 protocol is still being used. It was the predecessor to frame relay. Now both of those are starting to look like legacy technologies. There's ATM, there's HDLC, which is the default on a Cisco router, serial interface. There's even Ethernet that you could take and encapsulate over the WAN. There is MPLS. Now, MPLS is kind of interesting because MPLS, oh, and by the way, one they didn't mention here is PPP. Yeah, there's the point-to-point protocol. It's a popular one. Now, MPLS is kind of weird. MPLS we put right here at layer 2.5. Isn't that funny? We call MPLS layer 2.5 because we actually add a header to the layer 2 frame in between that and the layer 3 frame. And this header right here we consider layer 2.5, and that's where the MPLS information resides. Yep. Isaac asks about frame relay. All of these technologies, Isaac, are ways in which to carry the data over the WAN. So these are encapsulation wide area network protocols. We get in depth about frame relay in ICND2. Okay, so we can't get caught up in depth with frame relay here in ICND1. That is the stuff of ICND2. If you can't wait, if you are starving for it, Isaac, make sure you head up to our blog site, because I've got some great posts up there for you on the Stormwind blog on frame relay. Okay, so I think we might say a little bit more about it in this course, but I'm not sure. Okay, so what are the devices that are participating in the wide area networking? Well, certainly, whoa, what in the world just happened? I just jumped back in time. All right, one moment here. There we go. All right, so what are the devices that make this wide area network a reality? Well, no surprise, our routers are part of the story. The router may have built into it a channel service unit, data service unit, or as you can see, this device might be external and the router plugs into it. What this device does is it converts the signals for sending to a WAN switch of your service provider. So the service provider has WAN switches. As you know, we might use modems, either fancy new cable network modems or old-fashioned public switch telephone modems. We have devices called access servers, which are just fancy routers that take a bunch of different modem connections and send those to the WAN switch. So a bunch of different devices here. Now, in a WAN, in like a serial WAN connection, let's say we're using a EIA TIA 232 cable, or we're using a V.35 cable, or an X.21 cable, or many of the other cables that we run into when it comes to wide area networking. One of the concepts that I want you to be aware of is your Cisco routers function as what we call data terminal equipment. And then you plug into the service provider equipment, okay? And they function as what is called the data circuit terminating equipment. And these two entities are needed for this wide area communication to work. I like to think of the C as standing for clock, because this DCE device is actually going to provide the clock rate. Yep, it's going to provide the clock rate, the speed of the link. Okay? Now, one of the cool things that you can do with Cisco routers in the lab is you can set them up back to back. So let's say we have R1 and we connect it with a serial cable to R2. You can get a DTE to DCE cable so that the routers can simulate a service provider environment. Yep. And what you need to do is you need to figure out which end of the cable is the DCE end and go ahead and enter a clock rate on that interface. That is so cool. So you can go ahead in your lab and you can pretend like you are connected to an internet service provider. Let's see this on our routers. I have R1 and R2 connected by a serial connection. Let's look. Show IP interface brief. Yeah, they have serial 0/0 interfaces, and I connected them together. So I'll go into the serial 0/0 interface, and I'll say IP address 10.10.10.1. and I'll say no shut. And now let me go over to the R2 device. And on the R2 device, I'll say interface serial 00, IP address 10.10.10.1, 10.2, and the mask, and I'll no shut it. Okay. Now, let's see what happens. The interface changed to up, and the line protocol changed to up. Wow. So we just set up a WAN, and we can ping over this WAN. Now wait a minute. Who's providing the clock rate? Who is playing the role of the internet service provider? Well, if we take a look at the serial interface, aha! Cisco set the clock rate for us. Yeah, on this router, the 3700 series router, Cisco puts in the clock rate for us. Just understand, in your lab environment, you may need to provide that clock rate on the DCE side in order to get your simulated WAN circuit to work. If I had to find out which is the DCE side, you use the show controllers command. And it says, yep, this is a DCE cable you've got plugged in here, so you need to provide the clock rate. So the show controllers command is very valuable in the lab environment to see exactly what type of cable is plugged in and whether or not you need to provide the clock rate if you're in this back-to-back situation. Notice that this is very much a discussion that's really just relevant for your practice labs. Because in the real world, you're going to connect your router to your service provider and they're going to provide the clock rate. You don't provide the clock rate. So this is really just a discussion for our lab environments where we are practicing. Boy, different service providers offering different technologies are always going to be recommending or requiring different cable connections. Look at that. The network connections at the CSU, DSU are going to be all kinds of varying standards. Good news for you at the DTE side, it's a standard interface on your Cisco router. So great news for you. So obviously, you're just going to be going to your service provider and finding out exactly what physical media that you need in order to make the connections. So, wide area networks, so critically important for the connecting of many different local area networks. Here's a bit better list of our WAN layer 2 protocols. And remember, I like to technically call this one layer 2.5. Yeah, that's layer 2.5 right there. HDLC, layer 2, PPP, layer 2, frame, ATM, Metro Ethernet. All those are pure layer 2 wide area network options. Now, Cisco, there's so many WAN options today. Cisco loves to categorize them. And I really, really like this because, you want to sort them out, right? You want to get a hold of how many different WAN protocols there are in order to keep them all straight. You want to put them into buckets to categorize them. Let's start with the more legacy technologies, right? It used to be to do wide area networking, we used a switched approach, and particularly it was circuit switched, and we did the public switch telephone network and or ISDN. Remember these days? Remember the days of America Online when it first started? And to access America Online, you would connect via that PSTN modem, and you would hear all this screeching, and then you would make your real slow connection. That was a WAN connection using the public switched telephone equipment, and we called this circuit switched wide area networking. Well, nowadays, in an improvement on that, they went for a packet switched approach. And this includes frame relay, the predecessor to frame relay X.25, and ATM. ATM in a lot of textbooks is called cell switched, and it is put in its own category called cell switched. So please just be aware of that. You might see this as cell switched. The reason why they put ATM in its own category is because with ATM, you have all of the data chopped up into fixed little tiny chunks. And that data is given a small little header and then moved very quickly through the WAN infrastructure. So with ATM, we chop it up into little cells, and that's why, and then move them really, really fast. And that's why a lot of textbooks call that cell switching. What about the internet category? These days, it seems like everyone is using a broadband connection, either DSL or cable or wireless, in order to make their connection. But what if we're a really big, successful company like Apple, and we want to connect two of our headquarters, and we want guaranteed connectivity. We want guaranteed high-speed connectivity. We don't want to share our bandwidth with anybody else. This is when we fork out big dollars and we get a dedicated WAN connection. This is called a leased line. And this is where we get into terminology like T1, T3, and these refer to the speeds of the equipment. And so we literally lease a dedicated connection. Now, Bruce typed in an interesting thing. Bruce said, VPNs. Well, think about it. If you're doing this, you don't need a VPN because you have a dedicated circuit that no one else can use. Where VPNs get into the equation is here and here, right? Yeah. When we are using connections like the internet that everybody's using, that's when we want to tuck our WAN traffic into a VPN so that no one can see it. Pretty cool. Here's a look at some last mile and long range type WAN technologies. One that is not shown here is Metro Ethernet. Yeah, that's pretty cool. Metro Ethernet is high-speed Ethernet that can connect buildings in a city. And this is called a metropolitan area network. I mentioned it earlier. Shouldn't be on your test, but I just want you to be aware of that. You can literally have Ethernet as your WAN technology that's connecting your buildings. Here's a look at companies being connected via fiber optics. Fiber optics that have been buried under the ocean, literally, that can be used for wide area networking. So, pretty cool stuff. One of the technologies that we want to get into more detail on is these WAN layer 2 technologies, and I literally want to set one up with you. Okay? I want to set one up with you. Packet switch technologies are pretty cool because what you're doing is you're setting up a virtual circuit in the ISP's cloud. Yeah, so the ISP is taking in your traffic and they're giving you a circuit to get to the other destination. Now, again, this is shared, isn't it? Shared bandwidth. But now, I do want you to realize that when you contact the service provider and when you're working with the service provider, you go in there and you literally can create a contract with that service provider, and that contract will state how much bandwidth you're supposed to get, and you can get some bandwidth guarantees. But it is interesting that there's lots of people calling on the service provider for this packet switch technology. And technically, you're sharing that service provider's equipment. With digital subscriber line, we are taking the data and we are using a DSL modem in order to send it up to a device called the DSLAM at the service provider, and then they send it in to their high-speed switches. So DSL is another option. Remember, this one was in the internet category. Okay, this is one of the ones where we call broadband. Now, notice that with DSL, I want you to watch out for this. When you're talking to your provider about DSL, make sure you know exactly what type of DSL they're talking about with you. You see, there is symmetric DSL, and providers will often sell this as what they call business DSL. And your download speeds are equal to your upload speeds. Contrast this to what's often called consumer DSL or asymmetric DSL, and your download speeds will be relatively quick, but you will have substantially slower upload speeds. So just be sure you're aware of exactly what type of DSL service that you are signing up for. How about cable-based wide area networks? Yeah, we know these are popular today. The high-speed internet connectivity is coming to you over the coaxial cable that is used to carry your cable television. There is a cable modem that is used to actually have your data share that coaxial cable with the cable television. All of this, of course, adds up to the global internet. Just think about how amazing this global internet is, right? How absolutely remarkable it is. All of these individuals connecting in all of these different manners to share information through the ultimate wide area network.